Good evening, students. Today we are going to deal with another topic of periodic table, that is atomic radii. In this class, we are going to study what is atomic radii and what are the factors which do affect atomic radii. Firstly, if someone asks me what is atomic radii, then what will be my answer? It is a radii of an atom in the simplest sense. But actually, what is the radii of an atom? Guys, in ninth standard, it has been stated to us that an atom is spherical or circular in shape, where nucleus lies at its center, surrounded by the circular path which is known as shell or orbit. So, the radii of an atom is distance from the nucleus to the outermost shell. This distance from the nucleus to the outermost shell is known as atomic radii. Okay, that is, if I am showing this atom over here, that is, if I do take an atom in which I do have two shells, that is K and L shell. So what is atomic radii of this particular atom? It will be the distance from nucleus to the L shell is said to be the atomic radii of this particular atom. Okay guys, I hope that now you all are clear with the term atomic radii. Now, we are going to deal with the factors which do affect atomic radii. Factors affecting atomic radii. The first main factor is number of shell. If we are studying there in the book, it has been stated over there that number of shell is directly proportional to atomic radii. How come this happens? To understand this, I had shown a diagram where in the first atom is carrying only K shell, and in the second diagram, K and L both shell are being represented. So, if I stated that the distance from nucleus to the K shell is 5 centimeter, that is in the first atom's case, so the distance from nucleus till L shell will be greater than that of 5 centimeter. It is an understood fact. That means what? That means as we increase the number of shell, atomic radii will increase. So in these two diagrams, if we are observing these two diagrams, we came to know about that the second atom will be having greater radii as it do have greater number of shell. Okay, I hope that you all are familiar with the term number of shell and how come it affects the atomic radii. So now we move towards the second terminology, that is nuclear charge. In books, it has been stated that nuclear charge is directly proportional to number of proton and is inversely proportional to atomic radii. So again, how come this statement is being given? Firstly, when we see the relationship between nuclear charge and number of proton. The term nuclear charge means what, guys? Charge on nucleus. As we know that the nucleus do carry neutron and proton, where neutron is neutral and proton is positively charged particle. So, if the number of proton increases, this will increase what? Charge on nucleus. That is, nuclear charge increases. So, number of proton will be directly proportional to nuclear charge. So, I hope that the first relationship, that is nuclear charge is directly proportional to number of proton, is clear to you all. Now, we are going to relate it with atomic radii. So, before seeing this particular diagram, if we have to deal with the nuclear charge, just imagine our solar system. Increase in nuclear charge will be very much similar to that of increase in the gravitational pull of sun. That is, if my sun's gravitational pull is increased, then what do happen? The planet which were far away from the sun will come closer to that of sun, isn't it, guys? In the same manner, when the nuclear charge increase, which is because of increase in number of proton, it will result in greater nuclear attractive pull to the electron. As electron come closer, the size of shell, that is size of atom, decreases. है ना? So here are come two diagrams. In the first diagram, first structure of an atom, I had place plus 2 nuclear charge where first shell K shell is being shown with 2 electrons. In the second diagram, we do have atom with plus 3 charge. Similarly, the K shell is being represented over here with 2 electrons. But as we can see that in the second diagram, as the nuclear charge is increased, so the shaded line is actual position of our new shell, because now the nucleus is pulling electron towards itself, which results in decrease in nuclear charge. Hence the size will reduce, and we can state it now that with increase in nuclear charge, atomic radii decreases. Therefore it is having an inversely proportional relationship. I hope, guys, you all are very much clear with atomic radii and factors atomic radii now. In the next episode, we will be dealing with the term that how comes these factors do affect when we proceed in periodic table from left to right and from top to bottom.